we can sketch a direction field to this differential equation, and the direction field looks like this. The direction field looks like this. Those are circles, 3D. So notice one thing, the differential equation was this. That was the differential equation, or system of two differential equations, really. So that was the system of differential equations. The general solution is x of t equals some constant times cosine, and the other solution is y of t equals the same constant times sine of t. Okay, so we know that this is really the parametric equation of a circle. We mentioned this the other day. So those are exactly circle of a given radius. So when you specify a radius, for example, 1, then okay, so let's say this is the differential equation or system of differential equation. So there's many, many solutions, but you're looking for one specific solution, one function, and let's say you want to find the function that satisfies the following condition. So maybe, let's say, x of 0 is equal to, let's say, or let me put 1, and y of 0 equals 0. Okay, so now we have differential equation, system of differential equation, and an extra condition. So the solution is going to be the function, x of t equals, well, if I take the constant, the radius equal 1, then I have x of t equals cosine t, and y of t equals, well, sine t. And notice one thing, this pair of those two functions, they satisfy this condition because x of 0 is cosine of 0, but cosine of 0 is equal to 1. And then the other function, y of 0, which is sine of 0 is 0. So the function satisfies this differential equation as well as this initial condition. So what this is just one solution. So this is the equilibrium solution, which is the constant function 0, 0, is exactly this point. This point corresponds to this constant solution straight line. This solution corresponds to the circle with the radius 1. So radius 1, this is 1. Okay, radius 1, so this is this specific solution. So that's the circle of radius 1 and center 0. Okay, so this is the specific solution. Now, those are really the projection of the solutions to this differential equation. So how to think of this specific solution of this one? Okay, so now we are going to 3 dimensions, and this is what we'll be doing today. We'll be studying 3-dimensional spaces. So let's begin looking at this even now. So let me draw the 3-dimensional space. So let's say this is time. Okay, so let's see. Let me admit this person. Okay, so let's say this is the time t, the time axis, and let's say this is the maybe x-axis, and this is the y-axis, and this is the t-axis. Okay, so now what does this mean? What's the interpretation of this solution? Well, this solution lives in a 3-dimensional space. It's a pair of 2 functions, and they too depends on time. So this is the phase portrait of this solution. So that was differential equation. That was one specific condition, because differential equation has many solutions, so many of them. But this is differential equation, and that's the one solution that satisfies not only this differential equation, but also this initially prescribed condition. So the function at 0 is 1, and the other one at 0 is 0. So this point corresponds to this constant function t. This is the constant function, looks like straight line. This is the t-axis actually. This is the t-axis. When you look at this from this point of view, that's what you can see. The constant solution, this is the unique equilibrium solution to this differential equation, and it corresponds to this point. Now, how to think of this solution of this circle? What we do is, so let's see. When this is t0, and let's see, this is when t is 0, then we have cosine of 0. Cosine of 0 is equal to 1. So we are on, this is 1. And when t is 0, then y of 0 is sine of 0 is 0. So the y is 0. So we have exactly this point. And now what's going to happen is the following thing. When t, the time, goes to the positive direction, then what we're going to get is, okay, I tried to draw this, but I don't know if I can. This is difficult, kind of. Okay, this is the solution. So when you look at the solution from this point of view, what you can see is just a circle. It's just a circle. So this is how the circle looks like. This is the circle, and this is not really the solution, but rather that's a projection of the solution onto the xy plane.